All right, this is chapter 2.5, the fundamental theorem of algebra. How do you find all the zeros of a polynomial function? First of all, the fundamental theorem of algebra states that all polynomials with a degree greater than 0 have at least one zero in the complex number solution system. Complex number system. The linear factorization theorem states that a polynomial with degree n will have exactly n zeros in the complex number system. So the number of degrees that a polynomial have will tell you how many zeros it have. That's also how many solutions. That's how many x-intercepts it has. Well, should be careful about saying x-intercepts. It's how many zeros it has, how many because we're going to deal with imaginary numbers, so we're not necessarily going to see that that x-intercept. All right, lastly, if a complex number is a zero of a polynomial, then its conjugate will also be a zero of that polynomial. So we'll take a look at two quick problems here. Find the zeros of the function and write as a product of linear factors. So we're going to both find the zeros and we're going to write it as a product of linear factors. We take x squared, f of x equals x squared plus 10x plus 25. We can't easily factor that, so we're going to have to bring in our friend, the quadratic equation. So we have negative 10 plus or minus a square root of 10 squared, or b squared, which is 100, minus 4 times 1 times 23. All of that over 2a, so that'd be 2. Negative 10 plus or minus 100 minus 92. All of that over 2. Then let's just go, that's going to be plus or minus 8 over 2. Simplify that. Negative 10 plus or minus 2 root 2 over 2. And so I'm going to bring it back down here. X equals negative 5 plus or minus root 2. All right, these cancel out, or this cancels out. 5 cancels. Okay. So our zeros, coming back to the original question, what are our zeros? Our zeros would be x equals negative 5 plus root 2 and negative 5 minus root 2. And then the second thing it wants us to do is find the product of the linear factors. So we need to write each of these zeros as a linear factor. F of x equals 1 minus negative 5 plus root 2. And then 1 minus negative 5 minus root 2. And that's the product of our linear factors. Okay, slide over and let's look at number 2 really quick. Same thing, we need to factor this out. Let's see, we're going to f of x is going to equal, let's see, we can take x squared, let's give us our x to the 4th, and we go negative 9 plus 9. Right? In the case of here, right, this would be like our a squared minus b squared. That would equal a plus b. Oh, I'm sorry, square root of b. No, back up. Let's do it this way. I prefer x squared minus 9 equals 0. We want to find those zeros since the factor is built off of the zeros. X squared equals 9, so x equals positive negative 3. So here we have x minus 3, x plus 3. On this side, if we try to do the same thing, it's a little different because we have x squared plus 9 equals 0, x squared equals negative 9, x equals the square root of negative 9, x equals plus minus. this is going to be negative 9 times the square root of negative 1. So x equals plus or minus 3i, since square root of negative 1 equals I. All right, so come over here. This is going to be x plus 3i and x minus 3i. So in terms of writing the product of our linear factors, that's what we now would have. We would set this f of x equals, that's the product of our linear factors. What are our zeros? Well, x equals 3, negative 3, negative 3i, and 3i. In no particular order. Order doesn't really matter. Those are our zeros.